Good afternoon, students. Moving on to next topic, that is small sample test. In the previous lessons, we had learned how to do large sample testing or what are large samples and all. So as we had discussed already, any sample which is greater than or equal to 30 is considered as large sample, and if n is less than 30, that is considered as small samples. Okay, so the test for hypothesis of both these cases are different. For n greater than or equal to 30, we use large sample test, and for n less than 30, we use small sample test. Then now if we take large number of samples of small size, say suppose you are taking so many samples of size less than 30, we calculate the mean of each such samples. That means you are taking so many samples of size less than 30, okay, and we find the mean of all these samples. We find the mean of all these samples, and if you plot a curve, then we can see that the resultant distribution, means the curve so formed, is not normal, but that is we called as T distribution, students T distribution, and its shape is almost, a student's T distribution is almost like a this normal distribution only. So normal distribution, as you know, it's a bit more like bell shaped. Okay, and here for a normal distribution, we know the mean and variance is, mean is 0 and variance is 1, but for a T distribution like this, T distribution, its mean is 0 but its variance is not 1, it is greater than 1, and it approximates to 1 after taking so many samples, or size of sample becomes large, then it approximates to a normal variate. Okay, so and here also means it is from minus infinity to plus infinity, but it doesn't touch this axis. Okay, so that is a T curve we say. Now why this is T distribution? What is T? So this is like, its history was like that. This was introduced by a statistician called Gauss. Okay, W.S. Gauss. He was working with a company, with a brewery company in Dublin, Ireland, and which that company, that office did not allow the employees to publish their research work under their own names. So at that time, means those who were working also were very interested to study mathematics, and so many examples we have, so many mathematicians we have who had worked a lot, and then along with their work they carried out their maths researches and all. So like that, Gauss was such a man who did his research work being an employee of a brewery company in Dublin. Okay, so he cannot publish his work under his own name, so he adopted a pen name called as Student. So his pen name was the Student, and he published his research work under the name Student. And later on, it is come to know that, means it became famous as T distribution. Okay, that was the history behind this T name. T distribution is called because of that only. That is, it is published by Gauss under the pen name Student. Then now, what is this student distribution, and when is it used? So it is used when the sample size, it is used when sample size is less than 30, and mainly when the population standard deviation is unknown. So this is, you have to be very careful, that is the standard deviation of the population is unknown and the sample size is less than 30, and the test statistic is given by T is equal to x bar minus mu divided by S upon root of n minus 1. The actual formula of this, here this S is given as capital S, that is taking consideration of some other terms, terminologies we define that capital S, but the test statistic used for t distribution is x bar minus mu divided by small s upon under root of n minus 1. There S is the sample standard deviation. Sample standard deviation, which is given by the formula S is equal to under root of summation xi minus x bar the whole square divided by n, or as you know, S square will be, variance will be summation of xi minus x bar the whole square upon n. Okay, so t is equal to x bar minus mu upon s divided by root of n minus 1 is the statistic to calculate the t distribution. And here this t distribution is derived mathematically under the hypothesis that the parent population is distributed normally. Okay, now in this topic we need to understand one more terminology, which is called as degrees of freedom. Degrees of freedom. Now what is this degrees of freedom? So t distribution is this one. T is x bar minus mu upon s upon root of n minus 1, where s is the sample standard deviation, and the terminology which I told now is DOF, that means degrees of freedom. Now what is this degrees of freedom? So for an example I'll tell you what is degrees of freedom. Suppose we need to find the sum of three numbers. Okay, sum of three numbers. Say it is 15. Sum of three numbers is 15. Now how many numbers we are free to choose here such that the sum is 15? So sum of three numbers you have to find, means sum of three numbers is 15. So how many numbers you can choose as your own, means like without any constraint, how many numbers you can choose, or we can choose without any condition, or we are free to choose. So obviously it will not be the three numbers. Suppose if I am choosing 6 and say 5. So 6 and 5, then the third number you will get only after subtracting this 6 plus 5 from 15. So the third number will be 15 minus 11, that is 4. So you can choose these two numbers. Say for example, if someone else is taking it as, say if I am choosing it as 3 and 7. So sum of three numbers, two numbers I chose as 3 and 7, then obviously the this third number will be based on these two numbers. So that third number will be 15 minus 10, or the third number will be 5. Means if three numbers are given, you are free to choose only two numbers such that the sum is 15. So like in any case, suppose 5 numbers are given. Sum of 5 numbers, say sum of 5 numbers. Not only sum, it can be any other operation. Sum of 5 numbers is equal to say 25. Then how many numbers you can choose here, so that the sum of that numbers, all the numbers will be 25. Suppose I am choosing as 2, then 8, 4, 6. So I chose, out of these 5 numbers, I chose 4 numbers. Then the fifth number will be based on all this. Okay, so fifth number will be 20. That is, fifth number will be 25 minus sum of all this. So 25 minus 20, that is, for the fifth number will be 5. So if someone else is taking say 8, 4, 6 and 5, then that fifth number will be this total minus, or 25 minus this total, means you are free to choose 4 numbers. So like that, in any case, if n numbers are given there, then degree of freedom is n minus 1. So you are free to choose n minus 1 numbers from a group of numbers. So that is the meaning of degrees of freedom. So if n is 10, degree of freedom will be 10 minus 1, 9. If n is 20, degree of freedom will be 20 minus 1, that is 19. Okay, then, and one of the uses of this t distribution is, it is used to find mean of population from the sample. That means if sample mean is given, you can find the population mean from that sample. In short, you can find mu if x bar is given. That's it. Okay, so that is T distribution. Then some of the properties of this T distribution are, some properties are like that, as in the normal curve. So as I told earlier, then curve of this one means standard normal curve, you know, it is like this, and here this T distribution curve is almost like that, and but it is not, its mean is 0, both means are 0, but standard deviation of or variance of normal curve is 1, standard normal curve is 1, but variance of this T curve is not 1. So its shape is something like that, and both the curves extend from minus infinity to plus infinity. Then like normal distribution, this is also symmetrical to both sides and has mean 0. Then this is means, before doing this T-test we need to read the question well. That is, this can be used, or we assume that before doing a T-test we assume that the samples are drawn from normal population and they are random. So the sample should be taken from a normal population and they are chosen at random. Means already we had discussed in the first lecture. So they should be drawn from a normal population. And second is that, means what we assume to do T-test. The second point is that testing the equality of means of two population. And if suppose you are testing, if you are testing H0 is mu1 equal to mu2. If you want to test this, here we assume that their variances are equal. So that is one of the assumptions you need to make. That is, if you want to test the equality of the means of the population, means if you want to test mu1 equal to mu2 or not, population means are same or not, and then there we assume the variance sigma 1 square is equal to sigma 2 square. This is one of the assumptions, or two of the assumptions we need to do before doing a T-test. Okay, then here now we will see how to test using T distribution. So here testing, first of all, your first topic is here testing difference between means of two samples when the samples are small. Okay, so this is testing the difference between the means of two samples when the samples are small. In this case, what type of, so this is the first case, that is testing difference between means of two samples. So difference between means of two samples means x1 bar minus x2 bar. x1 bar is the mean of first sample, x2 bar is the mean of the second sample, divided by standard error, like we did in Z-test. Okay, same like that, only the statistic is instead of Z, here we write T, but here also under certain condition this can be even Z also. So this is the first one, testing difference between means of two samples when the samples are small. We use T equal to x1 bar minus x2 bar by standard error. Now where this standard error is, 2-3 formula are there. Standard error is equal to standard error. To find the standard error, case 1 we will see if sample size n1 plus n2 minus 2 is small. So why this is like this? Sample size of first sample, suppose n1 is the sample size of first sample, so degree of freedom is n1 minus 1. n2 is the sample size of the second sample, so degree of freedom is n2 minus 1. So together it will make n1 plus n2 minus 2. Okay, so if the sample size n1 plus n2 minus 2 is small, then we take an unbiased estimate. Then an unbiased estimate of the common population population standard deviation is given by SP, that is common standard deviation of the population. So SP is given by, this is under root of n1 minus 1 into capital S1 square. This S1 square and the S1 we used earlier, means this S1, this S, both are different. Okay, this is sample standard deviation, and this S which we use now is different. So I'll tell you what it is. Plus this is n2 minus 1 into S2 square divided by n1 plus n2 minus 2, where S1 is, capital S1 is under root of summation xi1 minus x1 bar divided by n1 minus 1. So here you consider the degrees of freedom. Okay, so xi1 minus x1 bar upon n1 minus 1, and S2 is given by under root of summation xi2 minus x2 bar the whole square divided by n2 minus 1. Okay, so that is this S1 and S2. This is a case 1, means if this is given, unbiased estimate of the population standard deviation is given, unbiased estimate of the common population standard deviation, then we use this formula. And secondly, if directly standard deviation of the samples are given, so standard deviation of samples are given, then there we use this SP, this is small sp, that is equal to under root of n1 small s1 square, which is the standard deviation, plus n2 s2 square upon n1 plus n2 minus 2, where this s1 is, s1 square or s1 is under root of simple standard deviation which you had already learned. So I1 minus x1 bar the whole square divided, whole square is here, divided by n, and s2 is under root of summation xi2 minus x2 bar the whole square. The square is under the root. Okay, the space is not there, so I am adjusting like this. So S1 is under root of summation of xi minus x1 bar the whole square, root inside the root square. Then S2 is some under root of xi2 minus x2 bar the whole square divided by n2. Okay, so this is what the standard deviations of samples are given, then SP is this one. So after this, in both the cases, after finding these two, we write this, that is T is x1 bar minus x2 bar divided by standard error. So in the case 1, means case 1 the standard error is given as, the standard error is this SP multiplied by numbers. Okay, so here therefore standard error is equal to SP into under root of 1 by n1 plus 1 by n2. It would be better before studying this if you practice the previous lectures. That is, there also we have already discussed what is standard error or how to calculate. I hope you remember there SP into, or this is sigma 1 square upon n1 plus sigma 2 square upon n2, all that formula. Okay, so it would be better if you go through that before studying this one. So here two formula we had studied, that is, if to use T distribution to test difference between means of two sample, then we consider x1 bar minus x2 bar divided by standard error, where the first case this is if the sample size n1 plus n2 minus 2 is small, then an unbiased estimate of the common population standard deviation, that is this formula we use to find the SP. Okay, so to find the SP we use this one, and if the standard deviation of the samples are given, then SP is under root of n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2, and standard error is given by SP multiplied by under root of 1 by n1 plus 1 by n2. Okay, so this is what we will be using to solve the questions.